Hi, good afternoon, everyone. My name is Dr. Sumit Mahajan. So today we put some light on the topic shielded metal arc welding electrode coatings development for power plant welds. So before starting this topic, I would like to uh, discuss some of the points. What do you understand by power plant? So this is some of the outline that we are going to discuss in next few minutes. First one is USC introduction. Basically, USC means the ultra supercritical power plants and their candidate materials. What kind of materials are used to build these kind of power plants? And there are certain welding processes. So why we use welding in the fabrication of those power plants, and what are the different fabrication issues in the dissimilar metal welding. So DMW means dissimilar metal welding. Dissimilar means we choose various metals and join them with the help of welding. So if the materials are not from the same family, so we call it as a dissimilar metal welds. So there are some of the issues that is related to these welds at a high temperature. The very common issue is the hot corrosion. So we'll discuss hot corrosion and its mechanism in the next slides. After that, the hot corrosion is a major issue. So we need to protect our materials or welds from the hot corrosion. So we'll also discuss some of the major aspects to protect the metals or materials from this hot corrosion. After that, there are various issues uh, with the different welding procedures and welding of the metals. So there are fabrications we will discuss, and then the fabrication process of SMAW electrodes. So we'll discuss why we use these electrodes and why these electrodes need to be prepared or developed to weld some kind of fabrications in different power plants. So as you can see on the screen, there is a general layout of the thermal power plant. So you can see the various components. First of all, we need to understand what is power plant. Power plant is used to produce electricity from the burning of the coal or fuel, or you can say the fossil fuels. The coal is burned and the coal produce the heat. By using that heat we boil the water. So you can see this is a boiler. If we wanted to boil the water in the boiler, the temperature of the boiler is approximately reached more than 200 to 300 degrees centigrade. And then there are some other components, as you can see, in superheater, economizer, air purifier. They have their certain functions in the working of power plants. So our main concern is the components which are operated at the high temperature. So as you can see, I have put some arrows to the one is boiler, the second one is superheater, and the third one is turbines. So these are some of the materials which are operated at the high temperature. So there is a one term which you've heard in the outline. One is USC, the ultra supercritical power plants. Basically, there are three type of power plants which are operating. The first one is supercritical. Supercritical power plants are those power plants where the operating temperature is near about 450 degrees centigrade. Means the components, the maximum temperature that reached in the those kind of power plants is 450. And then is ultra supercritical. The temperature of the ultra supercritical power plants is reaching near the 650 degrees centigrade. And now the working is going on to set up a power plants, advanced AUSC, the advanced supercritical power plant, where we are able to achieve the highest temperature 700 degrees centigrade. So why I'm discussing this topic, because these are some of the components like boiler, superheater, turbines, and these are some of the components which you are seeing below those power plant layer. One is superheater, steam pipe, water valve, tubing, boiler headers. These are some of the major components of the power plants in which the temperature may reach more than 450 degrees centigrade to 700 degrees centigrade. So if the temperature is too high in these kind of materials, the chances of the failure of these materials is very high. And some of the other phenomena that occur at a high temperature. So by those kind of things, the materials will fail, and we need to replace the materials, and the power plant working is somehow hampered. So So as you can see, the power plant is made up of these different components. So when the one component is has to be joined to the another. If I say if the boiler is operated at certain temperature, the superheater is operated at certain temperature. So every component has their certain temperature, and they are made up of different materials. So when they are made up of different materials, we need to join these materials because we have to connect one component to the other component. So by to connect these components, we use welding. We uh, weld those components together to perform a certain task. So if we are talking about the welding, so what is welding? So we'll discuss some how these components has to be joined. So welding is basically a fusion of materials. When there is one material, two material, with the help of heat, we melt those material and we let them solidify at a room temperature. So those two materials will solidify and make a joint, which is called welding joint. So welding joint is a permanent joint, and we require the welding joint to join different components of the power plants. So here are some of the introduction to the different components and why the welding is important. So if we're talking about the different welding components, the like boiler, steam header, or you can say turbines. So these are made up of different materials. So the material for those kind of power plants, the material should have certain properties. The here one you can see the figure, the material characteristics. So what should be the material material the characteristics? The first one is the tensile strength of the material should be high so that they can withstand the high temperature, and the tensile strength should be high. The second one is corrosion resistance. So definitely at a high temperature, the material should not corrode. If the material corrode easily, so we need to replace the material. So the material failure will happen. Third one is lower weight. As far as the weight concerned, the material should have a lower weight so that the performance of the power plant can be enhanced, and the material requirement should be low. The weldability, the material, because the welding is an important process to join the different components. So the material will be easy to weld. If the material will be hard to weld, so our cost and our procedure will get hectic. So there is a creep strength. At a high temperature, material fail due to certain issues. So the creep strength of the material is too high, and CT is the basically. So these are some of the characteristics which are required for a high temperature materials. So here you can see this is a turbine rotor. So this turbine rotor, there are different regions there is marked. So this turbine rotor is made up of different components. As you can see, the previous component is made up of ferritic steel, and the middle part, which in the middle part the heat is somehow more in this particular components. If we use the ferritic steel will easily corrode or easily fail. So that's why we use nickel material. So as you can see, there are certain junction at the ferritic steel and the ferritic steel junction. So there is a ferritic steel, the different steel nickel alloys are different. So there is a junction. So this is called dissimilar metal weld because this material is different. This material is different. So here you can see there are some of the component name is T23 and T91, T22, T91. This is a nomenclature of the steel. So these are some of the high temperature materials which are generally used to build these components. So if we're talking about if the very basic question is why we do not use same material to build all the components, because if we use the same material, if we are talking about we are going to use the carbon steel to build all the components. Carbon steel has a low resistance to corrosion and has a low creep strength and corrosion resistance. So as the temperature go beyond 200 or 300 degrees centigrade, it will be easy for carbon steel to corrode. So here you can see a one chart where you can see that there are a different material. So this is basically a relation between the metal temperature. As the temperature increases, the different metal, because the operating temperature for the carbon steel is near 400 450, because if the temperature go beyond the 450, we cannot use carbon steel because the carbon steel will fail easily. So there are some other chromium molybdenum steel, 9 to 12 chromium steel. So these are some of the steels which have a better corrosion resistance due to the presence of chromium and nickel. So as we move ahead, so this is a nickel based alloys. The nickel based alloys are called superior alloys, which can withstand a temperature up to 800 degrees centigrade. But on the other hand, they are 10 times more costlier than the carbon steel. So we need to select the material according to the operating temperature. So the cost and the corrosion, the other properties can be optimized. So these are some of the operations, welding operations, which we are used to build those components. So there is one of the basic component. This is the similar metal weld, because parent metal A, parent metal B, we have to build a joint. This is a weld joint. So these are some of the different processes. The very basic process is shielded metal arc welding, and it's also called the metal arc welding. So here you can see there is a term which is consumable electrode. So our area of interest is to produce or to develop these consumable electrodes. Okay, so this is a shielded metal arc welding in which there is a consumable electrode. So we use these electrode to melt the parent metal and allow the material to fill the cavity and allow the material to solidify and make a joint. So there is the next joint which is called TIG welding. This is a consumable electrode, and in the TIG welding, the non-consumable electrode is used. So I'm not going to much into the detail of these processes, because this is a limited time session. So these are some of the various welding procedures. There's gas metal arc welding, submerged arc welding, but my area of interest is this shielded metal arc welding, where the consumable electrode is used and we have to develop a coatings for these consumable electrodes. So, if we are talking about the different shielded metal welding process and different welding processes, so as you can see, this is a pie chart. So, all over the applications which are performed to weld various components. So, 42% of the welding work is performed by these welding process. You can see how important this SMAW process is, because this is a very easy to use and it's very portable. All the sighting work can be performed by using this SMAW. So this is a widely used process, and you can see the 34% is a GMAW and 13% GTFW, and SAW is 9%, and other welding techniques can be used. Those this the major work of the welding is done by this SMAW work. So here is the basic SMAW process, in which there is a base metal, so there is a consumable electrodes. So we need to provide a filler material by using this consumable electrode, and you can see these dotted things. This is called coating. So my area of interest is this coating, which is extruded on the base wire. As I have discussed, at the high temperature, the material undergoes to the oxidation, which is called corrosion. Because why this is called a hot corrosion? This is also called dry corrosion, because at a high temperature, the different basically in the power plants we use water. In the power plants we use coal. So some of the impurities like sodium and potassium or chlorine, they are already present in the power plant components, and at a high temperature they deposited on the material surface, and at the high temperature they hamper the heat dissipation. So when the heat is not dissipated properly, they cause thermal cycling to the material, and due to that thermal cycling, the scaling is on the material and the material will fail easily. Or you can say the material will fail from as it's designed life. So as you can see, there are some of the terms which is written. The metal and alloy sometimes experience accelerated oxidation when their surface are covered with a thin film of fused salt in an oxidizing gas atmosphere at an elevated temperature. So this is called as a hot corrosion. Hot corrosion is of two types. One is type 1 corrosion and type 2 corrosion, or you can say high temperature corrosion or low temperature corrosion. So high temperature corrosion is basically occur when the temperature is over 900 degrees centigrade. Why this is not 900 degrees centigrade? Because the baseline of this kind of phenomena is the melting point of the sodium sulfate, which is a very common salt is available is present in the power plant components. So when the hot corrosion is below the 884 degrees centigrade, you can say below the 700 degrees centigrade, this is called low temperature corrosion. So we need to make our material the hot corrosion resistant, because these hot corrosion, the failures in the power plant materials is due to this hot corrosion. This is a very basic or common phenomena which allow the materials to fail easily at a high temperature. So how the hot corrosion can be controlled? So there are three basic methods. By using these methods, we can control the hot corrosion, or you can say we provide the protection to the materials or welds which are operated at the high temperature. The first one is the basic is coating. So we provide certain type of coatings to the material so that the material can be protected from the hot corrosion, or you can say environmental impurities. The first one is diffuse coating. So I'll show you some of the figures. So this is a figure of diffusion coating. So we provide a coating to the material of like which has a high corrosion resistance, like aluminum oxide. So we provide aluminum oxide coating to the material, so that the material can be protected against the hot corrosion. So there is the second one is welding consumable. So these are welding. So this is core wire, and this is the flux coating. So my area of research is this to developing of this flux coating. So we can also use the welding consumable. Through the welding consumable, we impart some of the metallic components, or you can say some of the alloying components to the material, which will enhance the hot corrosion protection. The third one is thermal spraying. So we also provide thermal coatings to the material to help to improve its hot corrosion resistance. There is a overlay welding. We also provide a welding layer to the already made components so that the hot corrosion resistance can be improved. So there is a method of short peening and cold working and grain structure. So these are some of the methods. So we choose this method to protect the materials from the hot corrosion. This is welding consumables. Uh, Now, what kind of issues that we are facing uh, while uh, while making dissimilar metal belts in the. So first of all, the selection of core wires. So we basically, when we are going to use the two different material A and B, so which kind of consumable we can use, the matching with A, the matching with B, or the some other material which is in combination with the A and B. Selection of coating, what kind of flux coatings are there, how the components can be deciding, the coating factor, welding parameters, selection of weld joint design, automation of the welding. So these are some of the issues that are present when we are going to make a weld joint in the different component materials. So these are challenges and difficulties. So I'm not going into the much of the detail because there is a time constraint. So our area of interest is welding flux. So which we used to code the shielded metal electrode. Okay, so first of all, we need to understand what is the function of those welding flux coating. So basically, when we do welding, so there is stabilization of arc is very important. If the arc is not stable, your weld, the quality will not improve. So welding flux had some of the oxidizing agents. They're stable some of the oxide coatings, and they stable the arc so that the weld quality is improved and weld can be made easily. So these flux coating also provide a slag protection, because there is a welding pool when we melt the metal, so the material will melt and that is exposed to the environment. And when in the environment the moisture is there, some dust particles are there, and some of the hamper gases are there which hamper the material performance. Okay, and when there is no slag protection or the protective coating, so they will easily react with the molten pool and the weld quality will be hampered. So these you can here read that the temperature to protect the melt metal from the air and improve the mechanical properties. Okay, so these coating can also be used to add alloying materials, because some of the materials do not have the sufficient amount of alloying materials which will help to to save materials from the different phenomena like corrosion. So we can also add some of the chromium, nickel, or other alloying elements which will help to provide a certain kind of protection to the materials. So these also provide the deoxidizer. Deoxidizers are used to clean the weld. So when the welds are clean, the weld quality will improve. So this also provide a proper viscosity to the out of position welding, because there are different position welding, where horizontal, vertical, or overhead welding. So the viscosity is a very important parameter. So they use or provide a proper viscosity to the to the molten metal. So this is provide the slag to promote the slag detachability. If the slag is not easily removed, that will slag penetrate in the weld, and which hampers the weld quality and also weld properties. So we produce a smoother weld contour with a good wetting and reduce pattern and frame. So these are some of the major functions of a welding flux. So how the welding flux are made, and what are the various constituents of the welding flux. So these are some of the cellulose, limestone, lime, fluorspar, rutile. So these all minerals. So these we combine these minerals in a particular ratio to make those coatings, and then extrude that coatings to the different electrodes. So these are some of the different minerals, like alumina, iron, powder, silica. So these have certain properties. Why why we use this cellulose? So here are some of the functions, like gaseous protection, deoxidizer, slag former, viscosity control, arc stabilizer, binders, slipping agent, alloying agent. So every mineral has certain properties. If I'm talking about this rutile, so this is a titanium oxide, so which provide the deoxidizing agent, slag former, viscosity control, arc stabilizer, and also color of the coating, because this titanium oxide is black grayish in color. So this also provide a color to the coating, and with other. So there are various components. So according to the application, based on the application we are going to use, we combine those minerals in a certain particular ratio, and we define our electrode coating composition. So these are some of the selection of coating, why we use the what is the use of deoxidizer. So deoxidizers are the metallic powder which are used to remove the oxygen, because oxygen is very harmful gas for the welding, so that can cause the porosity and also weld cracking. So we need to remove the oxygen from the weld, so we use these metallic powders. So these deoxidizers react with the oxygen, form slag, and make our weld oxygen free. So this provide the arc stabilizers. Some are their alloying elements are there. We already discussed in the previous slide. So these are the selection of coating factor. Coating factor means, I told it earlier, that the electrode is made up of the core wire and the coating. So these are the coating factor is the electrode outer diameter divided by the core wire diameter. So basically, this is a coating factor. If we are generally electrodes are grouped into a three category. There's a light coated, where the coating factor is 1.2 to 1.35, medium coated, and heavy coated. If the deposition rate required is high, or you can say the filled cavity is more, so we use a heavy coated electrode, so that the filling can be done with proper time. So these are some of the electrode diameters and their ampere range, because the ampere range means how much current is required to melt the material. So this is the welding electrode coating procedure development. So there is a wire cutting machine. So basically the wire which is used as a filler wire is come into a spool, like spool of 5 meters. So we cut into length, because the standard length of the electrode is 250 mm to 350 mm to 450 mm. So we first of all we cut the wire. So we stack those cut wire to this hopper, or you can say feeder. So we hand in this feeder. So this, you can say, this is a flux containing a wire. So we mix them different powders, and we press those materials into this flux container. So when the flux container provide the flux, and this container the wire, so you can see this is a conveyor wire where the coating is extruded on the wire. So this is, you can say, this is opening where the electrode wire is coming with the cloth. And this is the preparation of edges, and you can see these are the manufactured electrode from this machine, and we bake those electrode, and use those electrode for a different purpose. So as the time constraint is there, so we need to end this session with this the topic, because why these electrode coating are important, and how the welding is used in the power plant. So the basic uh, introduction about the welding procedure, the welding coatings, and hot corrosion issues in the welding. So I hope you guys will like this session, and thank you so much.